Okay, this is a grade 8 review at the end of the year of all of the outcomes you should be able to or should have learned. These are 16 questions that deal with a whole bunch of different things. If you'd like to try them now, just press pause and try them if you haven't done them already. And if you have done them already, I'll give you the answers to each question individually. Here we go. The first question is a proportional reasoning. Now, it doesn't give the context of it. It could be $14 for five, I don't know, pens. Uh, if you spend $24, well, we wouldn't use pens there because it's going to be a decimal, for 5 pounds of peanuts, for example, that could be a ratio. How many pounds of peanuts could you get for $24? So there's a couple different ways you can do it. The first one is if you think about what did you multiply 14 by to get 24, and if you could figure out what you multiply 24 by, 14 by to get 24, you could multiply the same thing by 5 to get the actual amount of peanuts you could buy. So in order to find your multiplier, you can take your calculator, which I have down here, and I can take my calculator and go, I'll put that here. 24 divided by 14 equals 1.71. 1.714. That is actually what you multiply 14 by. If you don't believe me, watch. So I'll take my calculator again and go 14 multiplied by 1.7, oh, backspace, 714 equals, well, 23.996, pretty close. So we're going to say that because I rounded, it's there. So if I multiply this by 1.714, 5 multiplied by 1.714, I get approximately 8.57, excuse me, pounds, or 8.57, whatever. So it's approximately that. That's one way you could do it, okay? But we said that that's, when you use proportional reasoning, that's not the most efficient way. The best way you could do it is actually to create an equation. So if you take 14 over 5 is equal to 24 over x, you can actually use algebra to solve it. And one of the things we learned is a shortcut to solving proportions, or missing values in proportions, is to first multiply across the equal sign to create a coefficient variable, in this case 14x, and then multiply across the other way to get the other side of the equation. In this case, you get 120. So to solve for the missing x value, you can actually create this equation here, in which case I'm going to isolate it by dividing both sides by 14. And you get x equals whatever 120 divided by 14 is. And 120 divided by 14 is 8.57, which is the same answer we got down here, right? I have to use an approximate sign, so x is approximately equal to 8.57. And either way, I got the same answer. Okay. Question 2 says a square has an area of 25 square meters. What is the length of its diagonal? So the first thing you probably should do is draw it and put area equals 25 meters squared. And we know since it's a square, the area, if I square root the area, I would find out that the side length is actually 5 meters each. That's the first step you got to do. Now the second step would be to then, I'm going to write it in here too, 5 meters. 5 meters. I'm going to put a better 5. That's not very good. If I think about this diagonal here, that's what the question is. How long is that diagonal? If I erase this part here and erase this part here, and because it's a square, it has a 90-degree angle, what I really have here is a Pythagorean theorem question. So if I attach my squares to the legs of all three sides of the right triangle, this would have an area of 25 meters squared. This would have an area of 25 meters squared. And this would have an area of 50 meters squared. And we know that if the area was 49 meters squared of a square, side length would be 7. So the side length is really, the exact measurement is the square root of 50, or approximately 7.1 meters. So the length of the diagonal would be 7.1 meters. Okay, question 3 says prime factorize 180. Now, if you remember why we learned how to prime factorize, we prime factorized to actually figure out if a number was a perfect square. and if the prime factors could be rearranged to create two identical factors, then the number was a perfect square, and if it couldn't, it was not a perfect square. So if we look here, there's a whole bunch of different factors we can take out of 180, or ways to multiply to get 180. The one I'm going to use is 18 times 10. Neither one of these are prime. Both of them are composite, so which means we can break them down. This could become 2 times 9. 2 is a prime factor, so I'll circle it. 10 can be broken down into 2 times 5. Both of these are prime, so I'll circle those. 9 is composite, so we can actually break it down into 3 times 3, which are prime numbers. So when we look at the circled numbers, we have 2 times 2 times 3 times 3 times 5. Those are the 5 prime factors that you can multiply together to get 180. And that's the only prime factors that multiply to give you 180. So that's one way. So the question is, how many prime factors does it have? There are 5 prime factors. All right, the fourth question says 12.5% of $38. So the first thing you need to do is you need to realize this is 12.5% of $38, which can be thought of as being 12.5% of $38, right? Well, what is 12.5% as a decimal? Well, if we think about it as a fraction, percentages are out of 100. But we know in order to translate it to a decimal, we can't have a decimal in our fraction, so we have to get rid of that. We can get rid of it by multiplying by 10, which is enough to move the decimal one place over. Give us 125 over 1,000. And that is 125 thousandths. If we think about our place value, this is the tenths, this is the hundredths, this is the thousandths. So we have 125 thousandths. Our number ends in the thousandths, so therefore it's 0.125. Now, why is this important? Well, that means when I reinterpret this, I want to think of 125 or 12.5% as 0.125 of 38. Grabez-vous mon calculator. Go to decimal 125 times 38, and I get $4.75. So therefore, 12.5% of $38 is $4.75. Question 5, there are 10 parts to it. I'll just start here with the first line. So it says, change 1/200th to a fraction, a decimal, or a fraction. Well, the fraction is 1 over 200. As a decimal, I'm going to skip the decimal part, and I'm going to go to percent first. So 1 out of 200, to get as a percent, I want to think of it as being a fraction out of 100, or an equivalent fraction out of 100. Here I divided by 2, and here I divided by 2. 1 divided by 2 is 0.5. So therefore, as a percentage, 1 out of 200 is 0.5%. Now I can write it like that, or I can write it like that. Both are the same thing. So for question 6, it's a percent. It's 0.5% or 0.5%. Half of 1%. Now to change that to a decimal, I'm going to use this one right here, and I'm going to bring it right down over here. So 0.5 out of 100. If I multiply by 10 and multiply by 10, move my decimal over, I get 5 over 1,000, which is 5 thousandths, which is tenths, hundredths, thousandths. So as a decimal, it's 0.005. Okay. Now for the next one, right here, we have 0.001. We give the decimal, but it wants to know as a fraction. Well, that's pretty easy. 0.001 is 1,000th. So as a fraction, we simply have to write it as 1,000th. Both read the same way, so they're both written as 1,000th. For a percent, we want to make it into an equivalent fraction out of 100. To go from 1,000 to 100, I divide by 10. So I divide my numerator by 10. I get 0.1 out of 100, and therefore, that would be 0.1%, or 1/10 of a percent. Both of these are the exact same answer. For question 9 and 10, it says 1/4%, which could be written as 1/4%. They're both the same thing. I'm going to start with this number here because 1/4%, I'm going to first write it as a fraction. So 1/4% would be this, but we can't utilize that because it has a decimal in it. So I have to move the decimal twice, which means I'm going to multiply it by 100. Multiply this by 100. I get 25 over 10,000, which is what that would be as a fraction. As a decimal, I just have to read that. It says 25 10,000ths. Tenths, hundredths, thousandths, 10,000ths. 25 10,000ths looks like this. Question 11 is asking for the surface area of this rectangular prism. The easiest way to do it is to simply draw a net and to think about the area of all 6 faces. Okay, and I'll call this one the bottom. I'll call this one the right and the left. That should help. Okay, this would be the top if that was the bottom, and this would be the front, and this would be the back. Just to give us our orientation of our net. So the bottom of this is a 4 by 3, right? Because we can see it 4 by 3 right here. So the area of that bottom is 12 units, 12 square units. And if we think about the front is also 4 by 3, so it's also 12. The top and the bottom have the same, and the front and the back have the same. So all of those are actually a 4 by 3 rectangle, which gives them an area of 12. This right-hand side, we can see is 3 by 3, so the right is 9. And since it's a rectangular prism, the left would be 9 as well. That's 24, that's 24, that's 48. 48 plus 18 is 66 square units, or 66 units squared is the surface area of that rectangular prism. Question 12 is a division of fractions question. It says 2 3/4 divided by 1 1/5. The easiest way to approach this is to change both mixed fractions to improper. So we have 11 quarters, which is the equivalent value of 2 3/4, divided by 6/5, which is the improper version of 1 1/5. We know that dividing fractions can easily be done if you change it to multiplication of the reciprocal of the second fraction. So we're going to change it to, instead of 6/5, 5/6. Multiply the numerators to get 55. Multiply the denominators to get 24. That is 2 and 7/24. That's the answer. Question 13 is a order of operations question with an addition and multiplication. A half plus is not going to be done first, but the product of these two will be. 1/5 multiplied by 11 quarters is the same question. That'll give me 11/20, which is in lowest terms. So the product of those two is 11/20. I'll bring it directly below where the multiplication was. So instead of saying 1/2 plus the product of 1/5 and 2 3/4, I can say 1/2 plus 11/20. My common denominator will be 20. The equivalent fraction to 1/2 that has a denominator of 20 is 10. When you add those together, you get 21/20, which as a mixed fraction is 1 and 1/20. 14th question is a volume of a cylinder question. We have the diameter of 10 and the height of 4.5. I know it's disproportionate. It looks like the height is much longer than the diameter, but whatever. So for surface or for volume, our formula is the area of the base multiplied by the height of the prism. So our base is a circle, so we're going to use the area of the base being pi r squared, multiplied by height of the prism, which will use the variable h. I'm going to use 3.14 multiplied by the radius, which is 5 squared, multiplied by the height, which is 4.5. 3.15 multiplied by 25, multiplied by 4.5 would be the first simplification, because I have to do the exponents first according to BEDMAS. Take my calculator, 3.14 multiplied by, what was it again, 25? 25 equals 78.5 multiplied by 4.5. 78.5 oops daisy, clear. 78.5 multiplied by 4.5, which is the height. I get a final answer of 353.25. So the volume equals 353.25 cubic units, or 353.25 units cubed, because we don't know if they're meters or centimeters or what. Question 15 is an order of operations questions. We have a subtraction, a multiplication, and a division. In this particular case, we have to simplify the top part of our question and then divide that answer by -2. So -6 take away whatever -4 times +8 is, which is -32, divided by -2. -6 take away 32 is the easiest way is to change it to the additive inverse, or add the opposite. We would have 26 divided by -2. And 26 divided by 2 is 13. And a positive divided by negative would give you a negative quotient. So the answer is -13. Question 16 is asking you for the equation of this these 3 points. So they form a line. We can see that. All we have to do now is figure out what is the linear equation for that. So I'm going to make a table of values. Remember, this is my x-axis, and the up-down one is called your y-axis. So for the first point right here, my x coordinate is 0, and my y value is -1. For this one right here, my x value is 1, and my y value is 1. And for the third one, my x value is 2, and my y value is 3. Now to find the equation, you can simply write down the relationship between x and y and find your coefficient first. Your coefficient will be the difference of y divided by the difference of x. 2 divided by 1 is 2, so 2 is your coefficient. And your y-intercept, where the y actually crosses, or the line actually crosses the y-axis, is actually what your constant will be. So in this case, it crosses at -1. But if you didn't know that, you could actually substitute and simplify to figure out what that would be. I'm going to take this ordered pair. It doesn't matter which ordered pair you take. I'm going to take the 1, 1. Substitute the x for 1. Substitute the y for 1. Simplify and see if they're equal. If they're not, you have to figure out how you can make them equal. 2 take away 1 equals 1, which means your constant in your equation is -1. Question 17 asks you to graph. Okay, so for this one, it says 3x minus 1 equals y. So the first thing I'm going to do is just make a table of values. And I can randomly assign any 3 values for x. A simple one would be 0, 1, and 2. Okay? Once you have that, take your equation, and in each one of them, you substitute the x value that you gave. So in this case, the first x value was 0. So your y value in that first ordered pair, when x is 0, y will have a value of -1. If I change that to, instead of 0, change it to 1, I have 3 take away 1 equals y, or 2 equals y. 2. And if I change it again, instead of 1, change it to 2, I'll have 6 take away 1 equals y, or 5 equals y. Now that I have those ordered pairs, I can draw my Cartesian plane. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 5. The first ordered pair is 0, -1, which is right here. Second ordered pair is 1, 2, which is right there. The third ordered pair is 2, 5, which is right there. Connect your dots, or reasonably connect your dots, and you have the line that matches the equation. Question 18 is a algebra question. It says -10 is equal to -4 plus 5x. What's the value of x? The simplest way is to get rid of the constant first. In this equation, the constant's -4. Applying opposite operation would add 4 to both sides. -6 is equal to 5x. Divide both sides by 5 because that's what the opposite operation is. And you get x equals -1 1/5, or x equals -1.2. Question 19 is a distributive property question. Two ways to solve it. I'm going to do both for you. You could, equals 7. Equals 7. First way is to expand. So negative 2 times x, you have negative 2x when you expand that. And you have, instead, if you had two groups of negative 5, you'd have negative 10. But if you had negative 2 groups of negative 5, you multiply those together, you get positive 10. Now you just treat it like a regular two-step algebraic equation. Divide by negative 2. X equals positive 1.5. On the other side, you could actually divide both sides by negative 2. That's the other way to do it. Instead of having negative 2 groups, you would have one group of x minus 5 equals negative 3.5. Add 5 to both sides. X will equal still 1.5. Question 20 is your probability question. It says, what's the probability of spinning an odd number on the first spinner and a 1 on the second spinner? And in grade 8, you learned that independent events, the combined probability is the product of each independent event. So the first event, odd, you have 2 chances out of 3 to spin an odd number. In the second event, you have 1 chance out of 4 to spin the number 1. Multiply those together, you get 2 chances out of 12, which in lowest terms is 1 chance out of 6, which as a percentage is 16.6 repeating percent, or roughly 16.7% approximately. And the last question says, plot the points 1, 2, 3, 3, and 4, 5. So I will do so right now. So I'll go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. 1, 2 is right here, and we'll call that A. B is 3, 3, which is right here. And C is 4, 5, which is right up here. Actually, I'll put C instead. I don't need to put the coordinates. C. I better move my B out of the way there. Ungroup, hang on a second. Group, ungroup. Move that over here. And then what I'll do is I'll connect those dots. So it's a pretty weird looking triangle, but it's still a triangle. And then it says reflected across the y-axis, or y-axis, y-axis. So this is the y-axis here. So because A is 1 centimeter or 1 unit away from the line of reflection, and it's perpendicular, so we're going to put A prime over here. That is perpendicular. Actually, I better lift it up a bit. It's a little off there. Right around there. Let's just bring that up there. There we go. That's A prime. B is 1, 2, 3 units away. So our reflected point B prime will be 1, 2, 3. We'll be right over here. That's B prime. And our C prime is 1, 2, 3, where is it? 1, 2, 3, 4. 4 units away. 4, so it's going to be 4 this way. 1, 2, 3, 4. Right over here, C prime. Connect those dots. And we have the reflected image. That's the worst drawing ever of the triangle ABC. Okay, hopefully that helped.